Hello everyone, welcome to another episode of this series. And today we're gonna be only doing one question today, and yeah, let's go straight into it. Number 10 is state two quantities that are conserved in elastic collision. So in elastic collision, the two quantities conserved are momentum and kinetic energy. There's no energy loss, there's no kinetic energy loss, so the kinetic energy is conserved, and every object in a closed system must obey the laws of conservation of momentum. That means the momentum before the collision is the same as the momentum after the collision, right? So yeah, that's gonna be it for number 10A. So include number 10B. A machine gun fires bullet of mass 0.041 kilogram at a speed of 640 meters per second. And to calculate the momentum of each bullet as it leaves the gun. So let's calculate the momentum of one bullet, right? So momentum is gonna be mass multiplied by velocity. The mass is 0.014 kilogram multiplied by, and then we have speed velocity, which is 640 meters per second. Okay, and we just multiply these two values, 640, about like 8.96 kilogram meter per second. So this is gonna be the momentum of one bullet as it leaves the gun, right? And question number 2, explain why the soldier holding the machine gun experiences a force when the gun is firing. So a soldier here, our little draw diagram here, a soldier is holding a machine gun. Say that this is the machine gun, right? It's a really bad drawing. And it's a machine gun, he's holding a machine gun, and the bullets are firing, and the total momentum before he fires the gun is 0, because the bullet velocity is gonna be 0, and his velocity is gonna be 0. So momentum is gonna be 0 before the firing of the gun. So momentum is gonna be 0. So as he fires the gun, right? As he fires the gun, the bullet is shooting out. The bullets now have momentum, and this is the change in momentum. But that can't happen because in a closed system, momentum must be conserved, right? Momentum must be conserved. So that's why if the bullet has a momentum, so say this bullet has a momentum of this, momentum over here, there must be an equal momentum here to cancel out the total momentum. So the momentum after the firing is 0, the same as before the firing. So I hope you guys get that, right? So yeah, no, so you just explain that with text. I'm not gonna write it, but you get the idea. And consider number 3, the maximum steady horizontal force that the soldier can exert on the gun is 140 Newton. So a soldier can only exert like 140 Newton, right? 140 Newton this way. Right, 140 Newton this way. And calculate the maximum number of bullets that the gun can fire in 1 second. So let's say in this, like, look, I'll draw a vector diagram here, a momentum diagram, right? So this is the bullet's momentum, right? This is bullet's momentum, and this is the recoil, the normal force. I say normal. That has to happen because of the conservation of momentum. So if the soldier is like not the wait again, so the soldier gonna experience 140 Newton this way. You're gonna exert for 140 Newton this way, so he doesn't, go backwards. Yeah. So these two will cancel out, right? These two will cancel out, but as you cancel out, the bullet will have a momentum here, and this doesn't break the conservation of momentum here. This is the force. So yes. So this force is momentum. So the soldier is basically canceling out this the backwards movement, the backwards movement with a force of 140 newtons. So I think you guys get that, and then we'll calculate the maximum number of bullets that the gun can shoot. So it's simple. We just need to calculate how much force. So we need to calculate how much force. This is not force, this is momentum, but we can change that to force. So how much force does this one bullet has, and then we divide that by 140 to get the number of bullets producing a force of 140 newton approximately, right? So we already calculate the momentum. So momentum of one bullet is gonna be 8.96 kilogram meter per second, and then we can use the formula F equals to delta B by delta T, and this T is gonna be 1 second. He says it's 1 second, so basically it's gonna be force equals to delta B, because this is 1, right? So the momentum here is 8.96, so force is gonna be also 8.96 newtons. The one bullet is gonna exert a force of 8.96 newtons this way, right? So 8.96 newtons this way. So there must be an equal and opposite force, or Newton's third law. You can explain this with Newton's third law too, right? 8.96 newton. Right, this is one bullet. So how many bullets can they fire if the soldier is exerting 140 newton this way? Right, so that's the question you're asking. So I just need to just do this. 140. Yeah, I haven't write it. So amount of bullet, number of bullet. ULLET is bullets. It's gonna be 140 divided by 8.96 newton, and that would get about like 15. I got 15.625, so we can round it up to 15 bullets per second. Okay, so 15 bullets per second. So the bullets are being fired 15. So the gun is firing 50 bullets per second, and that is creating a force almost equal to 140 newtons. And so the soldier can cancel out this force so that he will go back. And I'm doing a really bad explanation. I hope you guys get that. So yes, this is gonna be the end of today's video. So yes, I'll see you guys tomorrow, guys. Goodbye.